Solving compound inequalities. Inequalities containing and. Two inequalities such as h is greater than or equal to 52 and h is less than or equal to 72 form a compound inequality. A compound inequality containing and is only true if both inequalities are true. The intersection is where the two inequalities overlap each other. Does everybody have this written down?
Oh, I was supposed to write it down.
So write down this compound inequality.
Where's the graph?
We will graph this in a minute. The inequality is -2 is less than or equal to x minus 3 and x minus 3 is less than 4.
Not possible.
So we will graph this. I want 4 right here. I want -2 right here.
Wait, so we don't solve this?
We're going to solve this. Well, okay, we're going to solve this first. What we do is we add 3 to each side, but there's 3 sides here. Okay, you treat it like this.
That's too much adding.
No, there's not. Okay, -2.
One.
-2 plus 3 is 1.
7. 7.
7.
This is funky.
Okay, so we graph this. Shh. This is 1 is less than or equal to x. So I'm going to put a closed circle around x. It said x is less than or equal to 7, so I'm going to put a closed circle around 7. What we do is we graph the intersection where x could be. It's in between the 2 points.
Oh, I have to graph of that.
Hush. What we can do, we can check this. Pick a number between 1 and 7.
6.9.
How about 3?
6.9.
Okay, let's do 3. What is 3 minus 3?
0. 9.
Is this true?
Yes. No.
Is 0 bigger than -2?
Yeah.
Is 0 less than 4?
Yeah.
Yes. And I caught a mistake. Okay, this is supposed to be an open circle. I apologize.
Wow.
Okay, because this was less than 4, not less than or equal to.
So, are we doing the same thing?
So x could be any number between 1 and 7. Could it include 1 or 7?
Yeah.
It could include 1, but not 7, right? As open circle. Write this inequality down. The inequalities here are y minus 3 is greater than or equal to -11, and y minus 3 is less than or equal to -8. So what we do is we solve both inequalities. This gives me y is equal to, or greater than or equal to -8. I solve this one, where I add 3 to both sides. Start over. That gives me y is less than or equal to -5. So what I do is I graph these points, -5, 6, -7, -8. It says y is greater than or equal to -8, so it's a closed circle around -8. Which direction are we going to? The right or left?
Left.
It says y is greater than.
Right.
So we're going this direction, right?
Yeah.
But let's graph the other one. Y is less than or equal to -5. So it's a closed circle around 5.
Yeah.
That's going to the left. So this is our intersection. Y can be in between these points.
Hold on. Are we not doing arrows or are we doing circles?
We're doing just circles.
What
Circles because they're ended.
What happened to shading it and going to the left or the right?
We did that. We went to the right for y is greater than or equal to -8, and we went to the left for y is less than or equal to -5.
Okay.
The intersection, okay, y has to be one in between these numbers. Y can be -8, Y could be -5, or it could be any number between. If it's true, if it's in between here, then we can plug it in and both of these inequalities will be true.
Absolutely.
Okay, these are compound inequalities, meaning they work together.
And you just said a
Inequalities containing or. Another type of compound inequality contains the word or. A compound inequality containing or is true if one of the inequalities is true. Union is the graph of the two inequalities. Alright? So with or, only one of them has to be true. With and, both of them have to be true. So here, write these two down. Inequalities are -2m plus 7 is less than or equal to 13. And the other one is 5m plus 12 is greater than 37. So we solve both. We subtract 7 on both sides. This gives me -2m is less than or equal to 6. I divide by -2. So m, which I changed the sign because I divided by a negative number, m is greater than or equal to -3. I solve this one as well. I subtract 12 to both sides. 5m is greater than 25.
9.
Divide by 5. M is greater than 5. So what we do is we graph, okay, we graph both of these because only one of them has to be true.
Wait, so what happens if this is and? What do we do when it says and?
They have to, one of them has to be true, okay? In this case, well, both of them have to be true when it's an and. In cases where or, only one of these has to be true. So we're going to graph this one. Okay, that's my 5. So m is greater than 5. I'm also going to graph m is greater than -3. Okay, going that way. So only one of these has to be true, so it looks like this. Last one, write this down.
Do it really slow, guys.
This is a plus 1 is less than 4, or a minus 1 is greater than or equal to 3. So only one of these has to be true. So what we do is we subtract 1 to both.
One is true.
A is less than 3. We add 1 to both sides. A is greater than or equal to 4. So we graph that. A is less than, so it's this way. It's a closed circle around 4. Going to the other way. So really, what's the only number that does not make this true? 3 or anything like 3.1, 3.2. Okay? Lower than 3 is included, right? A is less than. So A could be 2, A could be 1, right? Or A could be 4, A could be 5.
So a plus 1 is true.
Mm-hmm. Any questions?
Write this down.
There's your homework.